So good morning all of you. Today we are conducting the topic that is support vector machine classification. Okay. So basically before going for the classification, we are having a support vector machine part that need to understand. Is it okay? So now anybody knows about the support vector machine? What do you mean by the support vector? Definition itself, you can say that what do you mean by the support vector? Support vector itself is a vector. You can say that it is a kind of sample, right, or point that you are representing for drawing something on your quadrant, like x and y quadrant, or you have some multiple quadrant in that you are trying to draw this the graph, like you are some linear or non-linear kind of graph, right? So this is what your support vector. It means it's supporting to some kind of line, okay, a line or any kind of line graph, right? So based on that we are trying to get some samples, and that samples is based on your data set basically. So what kind of data set you have, that is obviously it is a labeled set of data set. Okay, labeled data set, you can say. It is not a raw, it is a labeled. It means some non-categorical information will be converted into the categorical part, right? Some non-value is converted into some numbers, or should be removed it from properly from your database, right? So in this case you are having some of the labeled of data set, and after that you are representing any two values or two attributes from the data set in the x and y axis. Okay, so based on that you have to first identify that which two column or two attributes are informations are important to represent on this x and y axis, or in this x and y quadrant, right? So based on that only you will try to get the classification for the given data set. Is it okay? So for like example of your employer yeah, employer data set, right? So in that employer data set there are so many informations are given: name of the employer, their contact number, their addresses. Again you have the informations related their age, their genders, salary, experiences, positions, everything will be there. But now in this case if you wanted to do the classifications for their salaries range, or if you wanted to do a salaries range, then already you did this classification in the regression, right? So in the, regression basically is not a part of classification. It's predicting some your categorical value, right? That is a part of your number, that is a salary, right, based on some experience. But in case of your classification, I already told you in the name-based classification that you can do the classification for the non-categorical information also. So what kind of non-categorical information? It may be like your position. Okay, so suppose you wanted to do the classification for the positions, that you have a multiple positions in the companies recruiting, and in that case you wanted to identify that how many people are placed on the position 1, placed on position 2, and placed on position 3, and you're doing the classification for that, right? Even you can have a multiple department, you can do the that how many employees are in the each department, that classification also you can do. So this is a classification is not only based is for only the categorical information, or not only for the number, but it is also for your part of what, the non-categorical information. Like you can identify the class of your that employer, that what class it is in the class 1, class 2. Even you can identify the position, okay, the classification for your their positions, right? That you can get in this classification as using any kind of classification, even in the naive and even in the support vector machine. But there are some changes or the difference evaluation parameters are there in the naive classification and in the support vector machine classification. So in case of support vector machine classification, you are calculating the multiple parameters as compared to your that neighbors classification, and even you can evaluate the multiple parameters for your support vector machines based on the multiple samples which is available, right? So this is what about your support vector machine classification definition, right? Now in this basically the linear classifier, based on the linear classifier equation. So you know the very well equation, the what kind of linear equation is that already have used in the regression classification, right? So the that regression classification equation that even you are using here, and based on that you are trying to fit the line in the given samples, whatever the samples we have distributed on the x and y coordinate, and these are the samples as you can check here. This is the samples. Are you getting? These are the samples, and for these samples basically see here, this is your x coordinate, this is your y coordinate, and these are the samples. Okay, so your data set, you are trying to identify the samples. Okay, so what kind of sample? Training and tested samples. You are placing some of the trend samples in the x and y coordinate, and you are placing here in the two part, one dark points, and here it is a one of the only in the circle part, small circle parts, right? It is not a dark. So there are two part of samples we have divided here, and whenever you are trying to classify these samples, then you should get a line between these samples, that these samples are classified in the this class, and these are classified in the one part of one side of your line will be get in the one classification, another part of your line will get in the another classification. So like this you can identify the classification. These are the samples from the one class. This is to be called as a +1 classification, denotes with the +1, and these are the from the -1. So accordingly you are trying to fit here the base fit line for this number of samples which are given over there. So now here you can check the multiple base fit line based on the line equation. Here that are the multiple base fit line you can get. Okay, so likewise you can identify one of the best fit line which is suit to get all samples should be classified properly in the +1 and -1 classes. Is it okay? So now this is like that you can have, suppose I have chosen this one is the line, this is a best fit line which I have chosen. You can see here in the graph that this is your best fit line. You can identify from the given multiple best fit line. So now in this best fit line uh, you can identify the margin for your line in case in your that straight line that you have drawn. So for that straight line or base fit line which you have drawn, you should identify the margin for the same. Okay, so now how you will identify the margin for this line? That is based on the sample which is nearer to the that line. Okay, which is nearer or we can touch, which can touch that specific line. Okay, so the one of the sample from your +1 class, one of the sample is from your -1 class. Okay, so here you can see here that I'm pointing that this one is one of the sample from the +1 class, and this is one of the sample is from your -1 class. So likewise you can identify one or more than one sample for getting the margin. Okay, but here you have identified the one sample from +1, and here you can identify the one sample from the -1 class, and accordingly you drawn this line or plane such a way that it gets one margin of your linear classifier. Okay, it will get the one of the margin of your linear classifier as a width that the boundary could be increased by before hitting the data point. So accordingly, you will try to get this margin. This margin is also called as a plane. This margin is also called as a plane. It means suppose you are drawing this line, okay, like that. And for that, this is one point and this is another point. And now this point to this base fit line, you are getting the distance. From the one sample from the -1 class, you are getting sample, one sample which is nearer to your base fit line, you are getting the distance from this to this line, and accordingly you are drawing this margin like that, and then it will forms your plane. So this is what this one of the +1 sample and this is one of the -1 sample which is nearer to your base fit line, and based on that you are drawing this margin, or this based on this you are drawing this base fit line, or your plane you can say. Okay, and that are also to be called as support vector. You are calling this points are as a support vector. It's supporting your complete margin. Okay, it's supporting your margin. So likewise, see, is it visible now properly? Okay, so this uh, margin, even you can maximize it by choosing the another sample which is little bit far from the that base fit line, so that you can maximize the margin. That is maximize your margin linear classifier, which is a linear classifier with the your uh, number of maximum margin, means you are trying to get the sum of maximum margin. So suppose you have a sample, two samples, right? Then in that case, if you have two samples and you are getting the sum of that specifically two samples to get the maximum margin linear classifier. So this is also called as a simplest kind of support vector machine, called as a LSVM. Okay, this is also to be called as a LSVM. It means, suppose, see here, suppose you are maximize the margin. So in that case, number of samples from the -1 classes you have increased, it is a 2. Okay, and one of the sample from the +1 classes. So you are increasing that samples to maximize the margin, and when it's maximize the samples, obviously it's maximize the margin. Okay, it means it get broader and broader. It get broader and broader, right? Initially it is less broader or thin margin, and when you're identifying the more samples for maximizing the your that particular border, or maximizing that margin, in that case your samples will be increased. So in that case, these are the samples which increase your margin, and that samples are nothing but your support vectors on that margins. Okay, that is to be called as the support vectors on that margin, and this is to be called as a linear support vector machine. That is the simplest kind of linear support vector machine classifier, right? So why it is necessary? Why the maximum margin is necessary? Intuitively, when this feels a safest, because see, whenever your margin is maximized, it means you are trying to get the very clear classification. Part of classification where we will be very clear in that case, right? If and that here also we have made a small error in the location of boundary, and this gives us at least a chance of causing a misclassification even. So even suppose some of the points which are not having a proper classes, like they have missed from their classes. Okay, neither in the +1, neither in the -1, and there some have missed somewhere, and we are trying to identify the sum of samples in the given graph, and accordingly we are trying to place in the either in one of the class, either in the +1 or in the -1, by calculating their respective errors. So that we are going to learn here, that how we are trying to get the fitting that specific samples in the that samples which are misplaced from the classes, right? And accordingly we are trying to fit either with some overfitting or underfitting part, or with your training of samples, or with a training of calculating some kind of errors for that sample, and we are trying to fit that sample in the proper one of the classification. Is it okay? So in this case, we are specifying a line and margin first, and identify your +1 margin and -1 margin, and this is your classifier boundary. Initially this is your classifier margin, and this is your plus plane or minus plane. Even in the given that base fit line, you are trying to get a margin, okay, and that margin is also called as a plane. I already told you कि margin को आप plane भी बुला सकते हो, ठीक है। तो प्लेन में जब आप आइडेंटिफाई करोगे कि उसका +1 क्लासिफायर कौन है और -1 कौन है, ये मार्जिन में आप बोलते हो। पर अगर प्लेन अगर रहेगा तो प्लेन में आप उसको प्लस प्लेन या माइनस प्लेन ऐसे भी बोल सकते हो, ठीक है। सो दैट is given here in the red part, that is this is your plus plane and this is your minus plane, okay. So this is what about specifying a line with margin. And for the plus plane, this is a given equation. Already you know the equation of line, and accordingly you will identify your plus plane and minus plane such a way that you are trying to calculate the classifier with the +1 value in the plus plane, and for the minus plane you are calculating the classifier with the -1 value. So whenever the value which is identifying for the given equation is greater than or equal to 1, then it will come in the class of +1 or in the plus plane, and if it is less than or equal to -1, then it will come into the -1. Is it okay? So this is what about your the classifier using the support vector machine based on your margin or the plane which you have identified for classifying a number of samples which either belongs to your +1 class or either which is belongs to your -1 class. Is it okay? So that is given here, and based on that how you are computing your margin width. So this is also given here, that how you are computing your margin width, okay. So you can get the margin width by calculating this m, okay. And now how you are calculating this m, that is also given in the next equation. So here you can calculate these values, plus plane, minus plane, and based on that you can get the vector w which is perpendicular to your plus plane, and you will try to calculate the values even for your that x plus and x minus, okay. So when you are getting the values for this x plus and x minus, based on that you can claim this x plus is equal to x minus plus lambda into w for the same value of lambda, okay. So in that case, why we are getting this? Because the line from x minus to x plus is a perpendicular to the plane, and so to get it from the -1 to +1, travel some distance in the direction of your w, and based on that we are trying to get the line, right? And after that, once you calculated that, you will try to identify or calculate this margin width, okay. And it is now easy to get this specific m value which is to be called as a margin width, right? So margin width you're getting in terms of a w and b. Margin width get in terms of your w and b, okay. So now here we can calculate it now. W into x of minus plus lambda into w, that I have already told you this equation, that how you are getting this equation, and then you are calculating this w, and after calculating this w you are putting or calculating the value of this lambda, and basically whatever value of this lambda you are calculating, that is nothing but your margin width. Is it okay? So simultaneously you have to calculate the equation for your both points basically. So if you have considered the two support vectors, okay, on the line, support vectors on the line. So for this two support vector, you are calculating the you are calculating the values for your x plus x minus, and after that uh, you will try to identify the value for your margin width, okay, value for the margin width that we have calculated here. So I have one example, that one example such a way that in which I have taken one line equation and 2 points, two support vectors, and based on that we are calculating this margin width. And after calculating this margin width, we are rewriting the equation to get the classifier. Okay, that classifier for your support vector machine. So that I will also show you that how I have calculated that the support vectors, margins, and their classifiers. So rewriting this equation and elaborating, after elaborating and rewriting, we'll get this equation. Okay, so again this equation is written here and calculated and written here. Even any somehow suppose some of the values or the samples which need to calculate with the suppose with the some soft margin or hard margin. I have already told you, in case of soft margin, your margin is like you're trying to get the samples which is nearer to that specific base fit line, and hard margin, it means you are trying to maximize it, right? And when you are trying to maximize it, it means there will be the samples which is far from your that specific line, and you need to calculate the error or this error for that sample, that how much long it is from your base fit line basically, right? And in this also you will try to calculate that soft margin as well as the uh, your hard margin. Okay, so this is what the calculation of your overall that base fit line. Okay, calculating of the error, even also for the samples which belongs to with your maximizing a width or the plane. In that case, how you are calculating the error with your R value, that is also given. And in detail this explanation is also given, that how we are calculating that specific error, right? So now the main thing is that how you will try to get the margins, either even it is belongs to your soft margin or either it is belongs to your hard margin. Is it okay? So now finally you will come up with the equation like your C of R by this is your error calculation for your hard margin. Basically जब आपका हार्ड मार्जिन आएगा या फिर आपका मैक्सिमाइज विड्थ होगा, विड्थ जब मैक्सिमाइज होगा तो आपको ये एरर कैलकुलेशन करना जरूरी है. ठीक है, in soft margin case there is no need to calculate the error, because see here in that case we are trying to fit in the one of the class. Okay, like for example there are the two classes for the student, like the first class division A which belongs to 80 to 90 percent of range, and B class which is a range from the 60 to 79, right? So in that case these are the range, but some of the student those belongs to the 91 92. So what we can do for such kind of student which is nearer little bit, there is some difference, so we try to fit in the A division class, right? And some of the student those who are in the range of 50 to 60, even we are trying to fit in the B class, right? But the student those who have ATKT have a so big difference, right? Big difference means there is getting a big margin. Okay, in that case we are trying to get the error, means not only based on some ATKT but based on the each and every subject result we are trying to get their result, and based on that we are trying to fit that error with one of the classification. Okay, or either he will be come in the next division which is need to identify. So likewise we are trying to get the classification under the support vector machine. Is it okay? So this is a part that you can learn in the support vector machine. Okay, either you can try to place your base fit line based on some samples, try to get the margin, even we are getting a margin such a way that that have a very thin margin to be try to fit a sample in the one of the class, like a +1 or -1 class, by fitting it without an error. Okay, and when you are maximizing margin, in that case it means there is a error. Okay, you are try to get the width equation. Based on that width equation, train the samples, and even training the sample, you will try to get the error for the sample which covers your that plane. Okay, which covers that plane, that is also to be called as the samples. Because of that samples, it is overfitting the classification. Okay, so this is what about your support vector machine. Now I'll also show you the one of the example sample for this solved example sample. So this is one of the solved example. You can see here that step 1, as you know, that we are bifurcating the samples. Okay, and trying to get the one of the best fit line. Step 2, you are getting the line equation with the your weight, supporting weight. Okay, so this is your line equation, and after that you will try to identify the class for your that line equation. So if it is greater than or equal to 1, then it is a one class. If it is less than or equal to -1, it is a another class. So this is a step 2. Step 3, get calculate the your this line equation, or elaborate your line equation for the given margin. Okay, means try to find out the margin for the best fit line such a way that you will identify this equation. Okay, so that you will get this total margin is computed by this equation. That is this is your equation that we have written your line equation like that, that is g of x divided by w. Okay, and accordingly you will get this line equation for calculating the margin. And for non-linear optimization, in that case I already told you, you will try to get the specifically you are try to get the error, and based on that you are rewriting the equation for the non-linear optimization task. That is, use your Lagrange's multiplier of lambda I. Okay, so based on that you are trying to get your weight, and accordingly you will get the equation. Here there are the two equation or the two samples. Okay, like you have a point 1 and this is your point 2 or sample 2. So based on this these two samples, okay, you are trying to first identify the equation, and you are putting that see, this is your 1 1 and this is your 2 2 3, and based on that you are representing in the form of equation. Okay, so reform of equation is a plus 2a plus w0 is equal to -1. Similarly for this, and using this point you have getting this equation, and based on this equation you are getting the value of your a, that is 2 by 5. Okay, so you are solving this two equation, getting the value of a as a constant, and then you are writing or finding out the weight value, that is w of 0. They're putting in this first equation that value of your a and rewriting this w0's equation with this value, that is minus of 11 by 5. Likewise you get to try to calculate your w bar also and w0 also. So 2 points we have find out, a value is 2 by 5 and 2a is a 4 by 5. And now whenever we are trying to find out this values, it means these are your support vector. Okay, and whatever equation you are rewriting from the support vectors, it means these are your support vector margin, or this is a classifier. Okay, so this I have shown you because so that you can understand it properly, that how you are finding out the samples for identifying your margin, and how you are rewriting the equation with the given samples to finding out your weight values and placing in the equation and rewriting that equation to get your support vector margin. Is it okay?